Good morning, dear students. Today we are going to do some more questions based on definite integrals. So it is 0 to pi x upon 1 plus cos square x dx. So I is equals to 0 to pi. I'm applying P4 pi minus x upon 1 plus cos square pi minus x dx. 0 to pi upon 1 plus cos square x. Cos 180 minus theta is cos theta dx plus, minus integral 0 to pi x upon 1 plus cos square x dx. Now see, this is same as is the question. So I could write it integral part, that is I is equals to pi times 0 to pi 1 upon 1 plus cos square x. Now cos square x, I'm doing with the technique that is going little different. 1 upon sec square x dx minus I. So 2I is equals to pi 0 to pi sec square x upon 1 plus sec square x. Now sec square x can be written as 1 plus tan square x. So pi 0 to pi sec square x upon 1 plus tan square x dx. Now we need to suppose tan x as t. Sec square x dx will be dt. Yes, Imanshi. Okay. See, bete, there was a confusion. Cos square 180 minus x is minus cos square x, but square will make that negative symbol as positive. Square will make that negative symbol as positive. So now we are supposing tan x as t. Sec square x dx equals to dt. 2I is equals to 2 plus t square dt. Need to change the limit. X will put 0, tan 0 will 0. X will put pi. What is the value of tan pi? It is again coming to be 0. And 0 to 0 means result will be 0. So we need to think some alternate technique for this. Now this thing you need to concentrate. Please note it. What I'm doing, this pi must be divided by 2 and multiplied by 2. Pi must be divided by 2 and multiplied by 2. Now I suppose you remember one property, that is 0 to 2a. Fx dx can be written as 2 times 0 to a. A means pi by 2, and the value of sine pi by 2, tan pi by 2, then we'll put here tan pi by 2. So tan pi by 2 will be not defined. So the limit will become not defined over here. This thing you need to remember from this concept. 0 to 2a I have converted, and then it became 2 times 0 to infinity now. One thing I forgot to write that I'm writing now. Pi was over here in the previous step. 2 to 2 will get cancelled. I is equals to pi times 0 to infinity 1 upon t square plus root 2 to whole square dt. That is 1 upon x square plus a square. 1 upon x square plus a square. So it will be pi 1 upon 2 1 upon a, sorry, 1 upon a tan inverse x upon a. Now the limit we need to apply 0 to infinity pi by root 2 tan inverse infinity minus tan inverse 0. Tan inverse 0 will be 0 and tan inverse infinity will be pi by 2. So it becomes pi square by 2 root 2. This is the value of the integral. This is the value of the integral. So it's really a wonderful question. I suppose you will be able to do this. Further, we are going for the next question. It is 0 to pi by 2 log sin x dx. Must take care of this question. This is one of the very important question. In this we will apply maximum number of properties. 0 to pi by 2 log sin pi by 2 minus x dx. That is I becomes equals to 0 to pi by 2 log cos x dx. 1, 2. So with these two things, we can add both equation 1 and 2. When we'll add both, 2i is equals to 0 to pi by 2 log sin x plus log cos x. Log a plus log b can be written as log a into b, means sin x into cos x dx. Now log sin x into cos x, I don't have any identity for it. So what I'm doing, I'm multiplying this with 2 and dividing by 2. So what it become, 2i is equals to 0 to pi by 2 log sin 2x dx minus 0 to pi by 2 log 2 dx. Log a upon b equals to log a minus log b. Log a upon b is equals to log a minus log b. Now further, for the next step, what I could do, the best thing, this I'm changing. Only this part, first of all, you must see. So with the green color, we are going 2i is equals to log sin 2x I'm supposing as t. So 2 dx will become dt by 2. Limit also we need to change. When we'll put x as 0, t equal to 2 into 0, that is 0. Then we'll put pi by 2, t equal to 2 into pi by 2, that is pi. It becomes 1 by 2, 0 to pi log sine t dt minus, okay, this I'm writing as it is, next sheet only will be able to do this. Now I'm writing this to the next slide. So it is 2i equals to 1 by 2, 0 to pi log sine t dt minus 1 minus 0 to pi by 2 log 2 dx. I suppose up to this there is no such doubt. Now see what I am doing in this step. X I am supposing as t with black pen. Now I am going 2i is equals to 1 by 2 times. Point to be noticed, we are converting x as t. There won't be any effect on the limit 0 to pi log sine x dx minus. Now I'm not writing, simplifying this. First of all, first part only we will simplify. So up to this, I don't think there is any confusion. Now again, I'm changing the color. Now this thing, last step which you need to take care. 2 multiply 2 divide. This step we have taken in the previous question also. 2i is equals to 1 by 2 times 2, 0 to pi by 2 log sine x dx. 2 to 2 cancel. 2i is equals to 0 to pi by 2 log sine x dx. 0 to pi by 2 log sine x dx. 0 to pi by 2. See this. 0 to pi by 2 log sine x dx. So that I can put in the question also. See, it is 0 to pi by 2 log sine x dx. That is, it is I. Now, log 2, 0 to pi by 2, 1 dx minus log 2, 1 will become x from 0 to pi by 2. So it becomes, sorry, minus log 2 pi by 2 minus x. I is going on the left hand side. So 2i minus I is equals to minus log 2 into pi by 2. I is equals to minus pi by 2 log 2. This is the question. Really, this is one of the wonderful question. Keep in mind, it is given 2 times in the NCERT. One is in the exercise and once in the example also. So this question, I'm telling you, it is one of the very good question, and it comes in the board examination also. This question comes. So please take care of this. Practice it at least 2 to 3 times. Then only you will be able to do such questions. Otherwise, you won't be able to do We have done this question also. One more question I'm taking that will make you understand the topic little more better. This question, I suppose each one of you will be able to solve. Once you have to practice, then only you will be able to solve it faster. Otherwise, it is sure that you will feel problem with this question. So it needs practice. Without practice, you won't be able to do this question. So let us move to the next question. Zero to pi by 2 cos x minus sin x upon 2 plus sin x cos x dx. Similar to this question we have done in the indefinite integral. I've told you at that time what were my words? Just see. I've told you whenever in the numerator it is given cos x minus sin x or cos x plus sin x or sin x minus cos x with the opposite sign to this, you need to suppose. So let cos x plus sin x equals to t, opposite sign just. Whatever is in between them, opposite sign, opposite to that we need to put. So cos x can be written as minus sin x, this t should, plus sin x can be written as cos x. Dx can be written as dt. We are able to see numerator became dt, but denominator yet we have not got in the same manner as is expected. We have not got it in the same manner as was expected. So squaring both the sides, sin x plus cos x equals to t. Squaring both the sides, sin square x plus cos square x plus 2 sin x cos x equals to t square. This will become 1, 2 sin x cos x equals to t square minus 1. Sin x cos x equals to t square minus 1 by 2. This we need to put in the question. So let us put the in the question. Still limit change is required. So that also we will do. Integral numerator becomes dt upon 2 plus sin x cos x can be put as t square minus 1 upon 2. Now limit change. When I'm putting 0, cos 0 minus sin 0. Sin 0 is 0, cos 0 is 1. Means t becomes 1. Lower limit becomes 1. Upper limit. Cos pi by 2 minus sin pi by 2. So it becomes minus 1. So ultimately we are getting 1 to minus 1. 1 to minus 1. LCM 2 dt upon 4 plus t square minus 1. Next slide. 2 dt upon 3 plus t square. Okay, now we need to simplify this. With one more property, we are taking the next step. I is equals to minus times minus 1 to 1. 2 I'm taking outside. 1 upon t square plus root 3 to whole square dt. So it become 1 upon under root a square minus x square. A square plus x square, sorry. So minus 2, 1 upon a tan inverse x upon a means t upon root 3 from the limit minus 1 to 1. Let us put the limit minus 2 by root 3. Tan inverse 1 by root 3 minus tan inverse minus 1 by root 3. Now you are able to simplify it. Tan inverse 1 by root 3 is pi by 6 and tan inverse minus x can be written as minus tan inverse x. So that will be easy for you to simplify. I'm not going to simplify it further. So this is your task to do, but it's a wonderful question. I suppose you have seen really a good question. Today's all the questions, whichever I'm taking, I'm trying to select the best one, but might be some more questions which we may miss. You can ask any of the time, whatever doubts you are facing related to these all the things. One more question I'm taking. So let us think. I 0 to 1 tan inverse 2x minus 1 upon 1 plus x minus x square dx. So what best I could do with this, I'm writing it as 0 to 1 tan inverse x plus x minus 1 upon 1 plus, and numerator is plus, so denominator must be with the negative symbol, minus x minus 1 into x dx. Now see, it becomes one of the identity tan inverse a plus b, tan inverse a plus b upon 1 minus ab. Ba is written by chance. So 0 to 1 tan inverse x plus tan inverse x minus 1 dx. Now further, I'm applying P4 in it. When we'll apply P4 in it, what it will become? I is equals to 0 to 1 tan inverse 1 minus x plus tan inverse 1 minus x minus 1 dx. 0 to 1 tan inverse minus, I'm taking common, x minus 1 plus tan inverse minus x dx. 0 to 1 minus tan inverse x minus 1 minus tan inverse x dx. I now see this and this. If I'm taking minus sign common in this, so I is equals to minus I, or it implies 2I equals to 0 or I is equals to 0. So integral of this will be 0. Similar to this question with cot inverse x, I have seen in the board examination, and same question also once has come, ditto. So similar questions are coming in the board examination. With the practice, we could do such type of questions. So take care of these questions also. Practice them. Once you see this question, I'm taking one more question. One question I'm showing you, this will also be a good question. Integral under root 10x plus under root cot x dx. Root 10x can be written as under root sin x upon x. So this is the thing. Now taking LCM. When we'll take LCM, it will be under root sin x cos x. Root sin x into root sin x, this will be sin x plus cos x dx. Now this question has come to the right place where we need to suppose sin x minus cos x equal to t. What hint I had given you, whatever is given with the opposite sign, we need to suppose as t. Now cos x plus sin x dx will become dt. Further squaring both the sides, will give you sin x cos x value. This question you have to simplify, means it is homework, but keep in mind this is one of the very good question. It is given in NCERT book as example also. So must take care of this question. This is really a wonderful and important question. So this was all for the day. Now, day after tomorrow, when we'll start the class, we'll be going to next chapter. You have to do this chapter nicely. Integral is one of the very important chapter. Revise as much you could. Tanuja, you can stop.